Hello guys and welcome back to another class of our course about the complete introduction to quantum computing. So in today's part of the course we are going to talk about the qubit. So yes, I know that at the beginning of this class we talked about the qubit and some other aspects, like for example superposition and some other things. But in this part of the course we are going to talk really more mathematically about the qubit. So yes, we're going to have a refresher about what exactly it is, but we are going to talk about some other concepts of the qubit, and as I said, the mathematical aspects of this amazing concept. So let's start. All right, so basically how exactly a qubit is created. So this is a little bit more theoretical, but to create a qubit you need an object that can attain a state of quantum superposition between two states. So for example, we can think of an atomic molecule can be one kind of a qubit. So basically this type of particle can spin and point in different directions in respect of a certain magnetic field. So basically if we have a magnetic field, we will have this particle that will be here and will spin in different directions. So this could be one type of qubit. Another way can be stripping an electron of the atom. So basically we are taking an electron from an atom and turn it into an ion. Then with the electromagnetic fields it's possible to suspend it in, well, we suspend it and it's gonna be in free space, and all this thanks to electromagnetic fields, so with the magnets. Then this would create a trapped ion quantum computer. So this is a way to create a quantum computer, well, to create qubits, to be able to create a quantum computer after that. So how a qubit is useful in quantum computing. So basically a qubit is, in quantum computing, it's the basic unit of quantum information. Well, quantifying information, I mean. So in other words, how we can see it, it's basically like the bit for the normal computer. For the classic bit. And basically without the qubit there is no quantum, there's no quantum superposition and there is no quantum computers. So this is why this is really useful in quantum computing. And this will bring us to our third point that asks us how a qubit is more powerful than a bit. So basically here, as I said, it's really a qubit is really more useful than a bit. Why? It's because it's able to operate more than one operation at a time. So basically a bit will be able to generate only one answer. So basically if we have two bits, we have two possible answers. If we have two qubits, it's different. We have 2 power n possible answers. So basically if we have 10 bits, we will have 10 different answers that are possible. But if we have 10 qubits, we can have 2 power 10 different answers, which is way more powerful. And this is where exactly is the power of the qubit. It offers way more operations in way less time. So basically operations that can take years to complete with a normal computer can take, let's say, seconds to complete with a quantum computer, maybe minutes. So basically it allows us to go way faster with our technology. So basically it'll allow us to make way more operations, and this open doors to way more things and more new technologies. So what are the fields of utility of the qubit? So there is not that much fields of utility of for the qubit. So basically it's really useful in physics. So all the mathematics that are around the concept of qubit are really useful there. It can also be used in mathematics. So basically, once again, I'm talking about the mathematics behind the qubit. The qubit itself is useful in quantum computing. So basically, as I said, this is the main item inside of a quantum computer. And basically this is like a bit for a normal computer. So we needed to be able to work with information. So the qubit is really useful in this case. and this is its main utility. So basically quantum computing could be its main utility, but all the theory behind the qubit, so basically all the mathematical and physical concepts behind this, can be really useful in different fields such as mathematics and physics. So basically all the fields that are around the qubit. Now, is it possible to build a qubit at home? Theoretically, yes, it can be possible if you guys have a lot of money and a lot of knowledge in this field. But in the majority of cases, it's not really possible. It's possible to work with different programs that allow you to, well, create different quantum algorithms, such as Microsoft Q, for example. Well, yeah, so such as those, well, IBM has this program, Microsoft has its own program as well. There are other programs that are being created that you guys can use to be able to work with the quantum algorithms. And once again, it's possible to make this, but to create a qubit at home, it takes, as I said, a lot of knowledge and also a lot of money, because once again, those, well, the things that you guys will use to be able to create this technology costs a lot. So in theory, yes, but in practice, it's really, really hard. So once again, this course was, this class was really theoretical, and my goal here is really to give you once again an introduction to the qubit, which is the main, the main concept in quantum computing when we are talking about storing information and transferring information. So that's it for this class, guys, and see you all in our next class.